Hello everyone, welcome back to my channel. Today we are going to see chapter 1 integers from class 7 mathematics CBSE. So previously I have uploaded the tricks that you can follow for different operations, and today we are going to see the important 1 marks that you have to focus. In this lesson I would have underlined few texts that is important for your revision exam or self-work. So please do take a note of it. So shall we start? Closure under addition. We have learned that sum of two whole numbers is again a whole number. For example, 17 plus 24 equals to 41, which is again a whole number. Okay, so this property is known as closure property for addition of the whole numbers. Let us see whether this property is true for integers or not. Following are some pairs of integers. Observe the following table and complete it. Here they have given you few statements and observation. So you have to fill it up with answers. Like you have to give the answers for these statements and write whether those are integers or not. Since addition of integers gives integers, we can say that integers are closed under addition. In general, for any two integers a and b, a plus b is an integer. So closure under subtraction. So here also they have given you a box, statements and observation. So for these statements give your answers and write whether the result is an integer or not. What do you observe? Is there any pair of integers whose difference is not an integer? Can we say integers are closed under subtraction? Yes, we can see that integers are closed under subtraction. Thus, if a and b are two integers, then a minus b is also an integer. Do whole numbers satisfy this property? Commutative property. We know that 3 plus 5 is equal to 5 plus 3, which is equal to 8. That is, the whole number can be added in any order. In other words, addition is commutative for whole numbers. Can we say addition is also commutative for integers? We have 5 plus minus 6, which is equal to minus 1, and minus 6 plus 5, which is equal to minus 1. So 5 plus minus 6 is equal to minus 6 plus 5. Are they following equal? They have given you few sums and they are asking whether these are equal. Try this with 5 other pairs of integers. Do you find any pairs of integers for which the sums are different when their order is changed? Certainly not. We say addition is commutative for integers. In general, for any two integers a and b, we can say a plus b equals to b plus a. This is the formula of commutative property which is highlighted. We know that subtraction is not commutative for whole numbers. Is it commutative for integers? Consider the integers 5 and minus 3. Is 5 minus minus 3 the same as minus 3 minus 5? No, because 5 minus minus 3 equals to 5 plus 3, which is equal to 8, and minus 3 minus 5 is equal to minus 3 minus 5, which is equal to minus 8. Take at least 5 different pairs of integers and check it. We conclude that subtraction is not commutative for integers. Now let's go to the next subtopic. Associative property. Observe the following example. Consider the integers minus 3, minus 2 and minus 5. Look at minus 5 plus minus 3 plus minus 2 inside the bracket and minus 5 plus minus 3 in bracket plus minus 2. In the first sum, minus 3 and minus 2 are grouped together, and in the second, minus 5 and minus 3 are grouped together. We will check whether we get different results. So now they are checking it with the help of number line over here. So we'll see whether they get different results. So for the first sum they have given it here in this number line, and for the second one they have given it here. So in both the cases we will get minus 10. From the first sum also we get minus 10, here also we get minus 10. So They say, therefore, these both are equal. Similarly, they said us to consider minus 3, 1 and minus 7 here, and you can solve this. Take 5 more such examples. You will not find any example for which sums are different. Addition is associative for integers. In general, for any integers a, b, c, we can say a plus b plus c grouped together, which is equal to a plus b grouped together and added with c. So this is a formula for associative property which is highlighted. So now we'll see the additive identity. So when we add 0 to any whole number, we get the same whole number. 0 is an additive identity for whole numbers. Is it an additive identity again for integers also? Observe the following and fill in the blanks. This one also they have given for you to fill it up. So the above examples show that 0 is an additive identity for the integers. You can verify it by adding 0 to any other 5 integers. In general, for any integers a plus 0 equals to a. 0 plus a also equals to a. This is the formula for finding additive identity. So they have given you try these box to check whether you understood this chapter. So you can try this and solve it using those tricks which I taught you. So here down they also have given an example. Okay, so here they have said us to write down a pair of integers whose sum is minus 3. So whose sum is minus 3 na? Whichever is correct we can write. Say sum is minus 3 minus 1 plus minus 2 is equal to minus 3. Or minus 5 plus 2 is equal to minus 3. Next, whose difference is minus 5? Difference is minus 5 means minus 9 minus minus 4 is equal to minus 5. Or minus 2 minus 3 is equal to minus 5. Whose difference is whose difference is 2. So C, minus 7 minus minus 9 is equal to 2, or 1 minus minus 1 is equal to 2. Next, whose sum is 0. Minus 10 plus 10 is equal to 0, or 5 plus minus 5 is equal to 0. For 0 you can write whatever integers you want. Can you write more pairs in these examples? You can just try to write more examples with for these questions. So in this page we have the questions of exercise 1. So next we'll go to the next topic. So you can just write these questions and then you can write the answers for these questions. Yeah, so they have given you 4 Romans, so you can write it down. Now let's get into multiplication of integers. We can add and subtract integers. Let us now learn how to multiply integers. Multiplication of positive and a negative integer. How to multiply a positive and negative integer? We know that multiplication of whole numbers is repeated addition. For example, 5 plus 5 plus 5 is equal to 3 into 5, which is equal to 15. Can you represent addition of integer in the same way? We have from the following number line, minus 5 plus minus 5 plus minus 5 equals to minus 15. But we can also write minus 5 plus minus 5 plus minus 5 is equal to 3 into minus 5. 3 times minus 5 is equal to minus 15. So they say therefore 3 into minus 5 is equal to minus 15. See, they also have given easy sum in this try these. You can just solve it using number line. Similarly, minus 4 plus minus 4 plus minus 4 plus minus 4 plus minus 4 equals to 5 times 5 into minus 4 is equal to minus 20. So this also you can show it in the number line easily, and they also have given two sums here, that also you can write it in a multiplicative form and you have to write the answer. Okay, so next we'll see how to find the product of positive integer and a negative integer without using number line. So let us find 3 into minus 5 in a different way. First, find 3 into 5. Don't take these symbols, just multiply them as whole numbers and then put minus sign before the product obtained. You will get minus 15. That is, we find minus 3 into 5 to get minus 15. Similarly, you can try for 5 into minus 4, which is equal to minus 5 into 4, which is equal to minus 20. Similar way you can also find for these two questions. They have given below. Yes. So next we'll go see how this method we can use for this question also. This is also simple. 10, while multiplying with 10, it's very easy. So 10 into 43 is equal to 430, and we have to add the minus sign before it. Minus 10 into 43 is equal to minus 430. Till now, we multiplied integers as positive integer into negative integer. Let us now multiply them as negative integer into positive integer. We first find minus 3 into 5. So, to find this, observe the following pattern we have. 3 into 5 is equal to 15. 2 into 5 equal to 10, which is equal to 15 minus 5. 1 into 5 is equal to 5, which is equal to 10 minus 5. 0 into 5 is equal to 0, which is equal to 5 minus 5. Minus 1 into 5 is equal to 0 minus 5, which is equal to minus 5. Minus 2 into 5 is equal to minus 5 minus 5, which is equal to minus 10. Minus 3 into 5 is equal to minus 10 minus 5, which is equal to 15. We already have 3 into minus 5 is equal to minus 15. So we get minus 3 into 5, which is equal to minus 15, which is equal to 3 into minus 5, also equal to 3 into minus 5. Using such pattern, we can also get for minus 5 into 4, which is equal to minus 20, equals to 5 into minus 4. Using patterns, find minus 4 into 8, minus 3 into 7, minus 6 into 5, and minus 2 into 9. Check whether minus 4 into 8 equals to 4 into minus 8, minus 3 equals to 7. Minus 3 into 7 equals to 3 into minus 7. Minus 6 into 5 equals to 6 into minus 5. And minus 2 into 9 equals to 2 into minus 9. Using this we get minus 33 into 5 is equal to 33 into minus 5, which is equal to minus 65. 165. We thus find that while multiplying a positive integer and a negative integer, we multiply them as whole numbers and then put a minus sign before the product. We thus get negative integer. Already I have said you in the shorts that while multiplying a positive integer and negative integer, I mean different signs, we have to multiply them as whole numbers. Then we have to add the minus sign in front of the product. So they have also given try these here. So we can check it with the following pattern. So here they say that in general, for any two positive integers a and b, we can say a into minus b is equal to minus a into b, which is equal to minus a into b. So this is the formula which you have to apply here if they ask this type of question. Multiplication of two negative integers. Can you find the product minus 3 into minus 2? Observe the following. Minus 3 into 4 equals to minus 12. Minus 3 into 3 equals to minus 9 equal to minus 12 minus 3. Minus 3 into 2 equals to minus 6 equal to minus 9 minus 3. Minus 3 into 1 equals to minus 3, which is equal to minus 6 minus 3. Minus 3 into 0 equals to 0 equals to minus 3 minus 3. Minus 3 into minus 1 equals to 0 minus 3, which is equal to 0 plus 3 is equal to 3. Minus 3 into minus 2 equals to 3 minus 3, which is equal to 3 plus 3, 6. Do you see any pattern? Observe how the products change. Based on this observation, complete the following. Minus 3 into minus 3 equals to 9. Minus 3 into minus 4 equals to 12. Now observe these products and fill in the blanks. They have also asked you to fill in the blanks, so I have filled one here. So we'll go to next page. Here also they have given the continuation of the same sum. You can fill it. So try these. They have given try these over here. This is also simple. You can try it. Next, from these patterns, we observe that minus 3 into minus 1 equals to 3 into 3 into 1. Minus 3 into minus 2 is equal to 6. 3 into 2 equals to minus 3 into minus 3 equals to 9, which is equal to 3 into 3. Minus 4 into minus 1 is equal to 4, which is equal to 4 into 1. So minus 4 into minus 2 equals to 4 into 2, 8. Minus 4 into minus 3 is equal to 4 into 3, which is equal to 12. So by observing these products, we can say that the product of two negative integers is a positive integer. When we multiply two negative integers, same sign, both have same sign. So when we multiply two negative integers, the answer will be in positive integer. We multiply the two negative integers as whole numbers and put the positive sign before the product. As I said you in the video that when you multiply them as whole number, then add the positive sign before the product if the question has same sign. Thus we have minus 10 into minus 12, which is equal to plus 120 or 120. Similarly, minus 15 into minus 6, which is equal to 90 or 90. In general, for any two positive integers A and B, they have given the formula here also. Minus A into minus B equals to A into B, and you have to add the positive sign before the product. So here again they have given you try these. This is also easy to find out. So you can try it when you're free. Here they have given a game. The questions are here. 5 questions are here. This is the game board they have given in the next page. They have also given 2 questions here about this game, I think. But this was also easy to complete. So this also you can complete and check whether you understood this lesson. So now we will see properties of multiplication of integers. So closure under multiplication. Observe the following table and complete it. So here also they have given a box with statements and there are fill-ups to fill your answers. So you have to write your inference such whether the product is an integer or not. Same which you got it for addition and subtraction in the book. What do you observe? Can you find a pair of integers whose product is not an integer? No, we can't find a pair of integer whose product is not an integer. However, whatever product it is, everything is an integer. This gives us an idea that the product of two integers is again an integer. So we can say that integers are closed under multiplication. You also have an equation that a into b is an integer for all integer a and b. They also have asked you to find the product of 5 more pairs of integers and verify the above statement. This one you have to verify by trying with 5 more pairs of integers. So, commutativity of multiplication. We know that multiplication is commutative for whole numbers. Can we say multiplication is also commutative for integers? We know that multiplication is commutative for whole numbers. But we have to check whether it's commutative for the integers. For that, to verify it, they have given this table. They have given two statements and you have to find the answer. You have to fill in the blanks, find the answer. From that, you have to write your inference such that 3 into minus 4 is equal to minus 12. Minus 4 into 3 is also equal to minus 12. So I have to write that 3 into minus 4 is also equal to minus 4 into 3. Same likely you have to write every questions which are given down. So what are your observations? The above examples suggest multiplication is commutative for integers. Multiplication is commutative for whole numbers, also for integers. Write 5 more such examples and verify in general for any two integers a and b. They also asked us to write 5 more examples and verify that in general for any two integers a and b, a into b is equal to b into a. If you multiply 3 into 4 also it gives 12, 4 into 3 also it gives 12. That only they are coming to say here with the formula. So next we will see multiplication by 0. We know that any whole number when multiplied by 0 gives 0. Observe the following products of negative integers and 0. These are obtained from the patterns done earlier. Minus 3 into 0 equals to 0. 0 into minus 4 also equal to 0. Then minus 5 into 0 is equal to same 0. And 0 into minus x is also 0. This shows that the product of a negative integer and 0 is 0. In general, for any integer a, when you multiply it with 0, it's also equals to 0. So whenever you multiply a negative integer or any integer a into 0, you will get 0 as the product. So next, we'll see multiplicative identity. Yes. So, we know that 1 is the multiplicative identity for whole numbers. Yes, 1 is the multiplicative identity for whole numbers. Check that 1 is multiplicative identity for integers as well. As this is multiplicative identity for whole numbers, we will also check whether it's multiplicative identity for integers as well. So, they have given a few patterns that show whether it is also multiplicative identity for integers. Minus 3 into 1 which is equal to minus 3, and same minus 4 into 1 equal to minus 4, 1 into minus 5 equals to minus 5, and hence it continues. This shows that 1 is a multiplicative identity for integers also. In general, for any integer a, we have a into 1 which is equal to 1 into a, or it's also equal to a. Whichever number if you take and multiply it with 1, you will get the same number as the answer as shown here. So what happens when we multiply an integer with minus 1? Complete the following. Minus 3 into minus 1 is equal to 3. 3 into minus 1 is equal to minus 3. Minus 6 into minus 1 is equal to 6. Minus 1 into 13 is equal to minus 13. Minus 1 into minus 25 is equal to 25. 18 into minus 1 is equal to minus 18. What do we observe? We observe that minus 1 is a multiplicative identity for integers. Is that true? No. Minus 1 is not a multiplicative identity. If they ask in true or false, like minus 1 is a multiplicative identity for integers, they have given a statement like this in true or false, means you have to click false. Why? Because 1 is the multiplicative identity, minus 1 is a wrong answer. So we have an important point which they have given here, and please do take a note of it. 0 is the additive identity, whereas 1 is the multiplicative identity for integers. For integers, 0 is additive identity, whereas 1 is multiplicative identity. We get additive inverse of an integer a when we multiply minus 1 to a. A into minus 1 is equal to minus 1 into a, which is also equal to minus a. So we'll go to the next page. Now we'll see about associativity of multiplication. So consider minus 3, minus 2 and 5. Look at minus 3 into minus 2 grouped together and into 5, and minus 3 into minus 2 and to 5 is grouped together. In the first case, minus 3 into minus 2 grouped together and into 5. In second, minus 2 and 5 are grouped together, whereas 3 is outside, minus 3 is outside. So we see that minus 3 into minus 2 grouped together into 5 is equal to 6 into 5 equals to 30. And minus 3 into minus 2 into 5 grouped together is equal to minus 3 into minus 10, which is equal to 30. So we get the same answer in both the cases. Thus, minus 3 into minus 2 grouped into 5 equals to minus 3 into minus 2 into 5 grouped case. So these both cases are equal. And now they have also given another question. So this one also you can solve and see. This is an easy sum. Does the grouping of integers affect the product of integers? No. The grouping of integers does not affect the product of integers. In general, for any three integers a, b, c, to check the associativity of multiplication. In multiplication, if you want to check the associativity, you have to use this formula. A into B grouped into C, which is equal to A into B and C grouped. Take any 5 values for A, B and C each and verify this property. You can take 5 values for A, B and C, any value, and use this formula to solve it. Thus, like whole number, the product of 3 integers does not depend upon the grouping of integers. and this is called the associative property for multiplication of integers. Distributive property. We know that 16 into 10 plus 2 is equal to 16 into 10 plus 16 into 2. Distributive of multiplication over addition. Let us check if this is true for integers also. Observe the following. Minus 2 into 3 plus 5 equals to minus 2 into 8, which is equal to minus 16, and minus 2 into 3 plus minus 2 into 5 equals to minus 6 plus minus 10, which is equal to minus 16. So, minus 2 into 3 plus 5 is equal to minus 2 into 3 plus minus 2 into 5. Same type of solutions they have given here also. And so can we say that the distributive of multiplication over addition is true for integers also? Yes, the distributivity of multiplication over addition is true for integers also. In general, for any integers a, b, c, a into b plus c is equal to a into b plus a into c. Take at least 5 different values for each of a, b, c and verify the above distributive property. They also have said they have given the formula. So they are saying us to take the values, different values for 5 questions and just to verify this distributive property. Okay. So next they have given, try these here. These 2 questions we have to verify what property is it. This is, while looking onto it, it seems you know that this is distributive property, but you have to verify whether these both are equal to each other or not equal. So next, now consider the following. Can we say 4 into 3 minus 8 is equal to 4 into 3 minus 4 into 8? Let us check. 4 into 3 minus 8 equals to 4 into minus 5 is equal to minus 20. 4 into 3 minus 4 into 8 is equal to 12 minus 32, which is equal to 20. So, 4 into 3 minus 8 is equal to 4 into 3 minus 4 into 8. Look at the following. Minus 5 into minus 4 minus minus 6 equals to minus 5 into 2, which is equal to minus 10. Minus 5 into minus 4 minus 5 into minus 6 is equal to 20 minus 30, which is equal to minus 10. So, minus 4 into minus 4 in minus 6 equals to minus 5 into minus 4 minus 5 into minus 6. Check this for minus 9 into 10 minus 3 and minus 9 into 10 minus 9 into minus 3. You will find that these are also equal. In general, for any 3 integers a, b, c, a into b minus c equals to a into b minus a into c. Take at least 5 different values for each of a, b and c and verify this property. Now again, they have given try these for this type of question. And you can try this using the formula given above. The formula is a into b minus c, which is equal to a into b minus a into c. Here they have given exercise 1.2 and this one also you can practice for exams. So next we'll see division of integers. So we know that division is the inverse operation of multiplication. Let us see an example for whole number. Since 3 into 5 is equal to 15, So 15 divided by 5 is equal to 3 and 15 divided by 3 is equal to 5. Similarly, 4 into 3 is equal to 12, gives 12 divided by 4 equals to 3 and 12 divided by 3 equals to 4. We can say each multiplication statement of whole numbers, there are two division statements. Can you write multiplication statement and its corresponding division statement for integers? Observe the following and complete it. They have given a table, they have given multiplicative statements, and they also asked the corresponding division statements. So we have to write the answer here and then we have to write the division statements here. So this is also easy. They might ask questions like this also. They might ask like, what is the inverse of multiplication? Or they can also ask to write the corresponding division statements of these multiplicative statements. So from the above, we observe that minus 12 divided by 2 is equal to minus 6. Minus 20 divided by 5 is equal to minus 4. Minus 32 divided by 4 is equal to minus 8. Minus 45 divided by 5 is equal to minus 9. We observe that when we divide a negative integer by a positive integer, we divide them as whole numbers and then put a minus sign before the quotient. When we divide a negative and a positive integer, we have to divide them as whole number and put the minus sign before the quotient. So they have given try these. This is also easy. We will discuss it. Minus 100 divided by 5 is equal to. So these are all easy peasy questions. So you can try it whenever you're free. So we observe that 72 divided by minus 8 is equal to minus 9. 72 divided by minus 9 is equal to minus 8. And 50 divided by minus 10 equals to minus 5. 50 divided by minus 5 equals to minus 10. So we can say that when we divide, this is important. When we divide a positive integer by a negative integer, we first divide them as whole numbers and then put a minus sign before the quotient. In general, for any two positive integer a and b, a divided by minus b is equal to minus a divided by b, where b is not equal. Okay, if you will think that b can also be 0, but b is not equal to 0. This is also important. This is a formula to find positive integer divided by a negative integer. So can we say that minus 48 divided by 8 is equal to 48 divided by minus 8? Let us check. We know that minus 48 divided by 8 is equal to minus 6 and 48 divided by minus 8 is equal to minus 6. So, minus 48 divided by 8 is equal to 48 divided by minus 8. I mean both are equal. Minus 6 and minus 6. Minus 6 is equal to minus 6. Check this for 90. The 90 divided by minus 45 and minus 90 divided by 45. And also the second question is minus 136 divided by 4 and 136 divided by minus 4. Next, try these. Find 125 divided by minus 25, 80 divided by minus 5 and 64 divided by minus 16. They are asking you to try these, whether you understood this concept what we studied here. I mean, for this we have to use dividing a positive integer by a negative integer. We have to divide them as whole number and then put a minus sign before the quotient. I think you all understood. We'll go to the next thing. So, lastly, we observe that minus 12 divided by minus 6 is equal to 2. Minus 20 divided by minus 4 equals to 5. Minus 32 divided by minus 8 is equal to 4. Whereas minus 45 divided by minus 9 is equal to 5. So we can say that whenever we divide a negative integer by a negative integer, when we divide both negative integers, same sign. So we first divide them as whole numbers, then put a positive sign. In general, for any two positive integers a and b, we have to use this formula. Minus a divided by minus b equals to a divided by b, where b is not equal to 0. So here also they have given another trace where the negative integers in both the side of the operator where the same sign. So I also taught you the trick. So if you forgot, you can again go see that video. Minus 36 divided by minus 4, minus 201 divided by minus 3, and minus 325 divided by minus 13. So now we'll see properties of division in integers. Observe the following table and complete it. What do you observe? We observe that integers are not closed under division. Okay, they're saying that the integers are not closed under division. So they have given statement, inference. Here also they have given two statements and inference. So you have to complete here. They already completed here and you have to write your inference by seeing this. So justify it by taking 5 more examples of your own. We know that division is not commutative for whole numbers. So remember that division is not commutative for whole numbers. Let us check it for integers also. You can see from the table that minus 8 divided by minus 4 is not equal to minus 4 divided by minus 8. Is minus 9 divided by 3 the same as 3 divided by minus 9? Is minus 30 divided by minus 6 the same as minus 6 divided by minus 30? Can we say that division is commutative for integers? No, division is not commutative for whole numbers, also for integers. For both, it's not commutative. You can verify it by taking 5 more pairs of integers. Like whole numbers, any integer divided by 0 is meaningless, and 0 divided by an integer other than 0 is equal to 0. For any integer a divided by 0 is not defined. When 0 divided by a is equal to 0, for a is not equal to 0. When we divide a whole number by 1, it gives the same whole number. Let us check whether it's true for negative integers also. So, however, when you divide a whole number with 1, you get the same whole number. If you divide 2 divided by 1, you get 2. So, likely, they also are trying it for negative integers to check whether it applies for them also. Observe the following. Minus 8 divided by 1 equals to minus 8. Minus 11 divided by minus 1 equals to minus 1. Minus 13 divided by 1 equals to minus 13. So, however, when we think, we get minus 25 here. Yes, however, the same number repeats everywhere. Minus 37 divided by 1 is equal to minus 37. Minus 48 divided by 1 is equal to minus 48. So, next, this shows that negative integer divided by 1 gives the same negative integer. So, any integer divided by 1 gives the same integer. Any integer divided by 1 gives the same integer. In general, for any integer a, the formula is a divided by 1 equals to a. Whatever we divide with 1, the same number comes. So, when we divide it with a, so the answer will come as a only. So, I think it's clear. Next, what happens when we divide any integer by minus 1? Complete the following table. So, they have given minus 8 divided by minus 1, which is equal to 8. Why? Because same negative integer in both the sides of the operator. So, you have to divide and write the positive sign. So, minus 25 divided by minus 1 is equal to 25. 11 divided by minus 1 equals to minus 11. Why? Because here it's positive and here it's negative. Here both are negative, so we have to write 37. Here 13 divided by minus 1 is equal to minus 13. Why? Because here it is a positive 1. Minus 48 divided by minus 1 is equal to 48. No minus sign. Why? Because both have negative integer in both the sides of the operator. So, what do you observe? We can say that if any integer is divided by minus 1, it does not give the same integer. Can we say minus 16 divided by 4 divided by minus 2 is the same as minus 16 divided by 4 divided by minus 2? We know that minus 16 divided by 4 divided by minus 2 is equal to minus 4 divided by minus 2 is equal to 2. And minus 16 divided by 4 divided by minus 2 is equal to minus 16 divided by minus 2, which is equal to 8. So, these both are not equal when we verify it. We have to do a trial of it. Like we have to work it out, and if both the answers does not come correct, like for the first case the answer came as 2. For the second case the answer came as 8. So these both are not equal. Either it should be 2 and 2 or else it should be 8 and 8. As it's not that, so we have to write minus 16 divided by 4 divided by minus 2 is not equal to minus 16 divided by 4 divided by minus 2. So, can you say that division is associative for integers? No. Division is not associative for integers. Verify it by taking 5 more examples of your own. You have to take 5 more examples that you can create by your own, and you have to try verifying it. Is 1 divided by a equal to 1? 2. A divided by minus 1 equals to minus a. For any integer a, take different values of a and check. So next. So we'll see the examples. Example 2 they have given here. Why? Because example 1 we saw in multiplication. Example 2 we are seeing here. In a test, plus 5 marks are given for every correct answer and minus 2 marks are given for any incorrect answers. First question is, Radhika answered all questions and scored 30 marks through. She got 10 correct answers. Actually, Radhika answered all the questions that were given in the test and she scored 30 marks as she got 10 correct answers. J also answered all the questions and scored minus 12 marks, though he got 4 correct answers. How many incorrect answers had they attempted? So we'll check. For the first question, I mean Radhika's question, marks given for 1 correct answer is 5. So marks given for 10 correct answer is 50. Radhika's score is 30. Marks obtained for incorrect answer is 30 minus 50, which is equal to minus 20. Marks given for 1 correct answer, one incorrect answer is equal to minus 2. Therefore, number of incorrect answer was minus 20 divided by minus 2, which is equal to 10. So, the number of incorrect answers in Radhika's answer sheet were 10. They said they also given the solution, so we can look on to it. Marks given for 4 correct answer is 5 into 4, which is equal to 20. This is for J's marks. Okay. Second question, J's marks question. Okay. Marks given for 4 correct answers are 5 into 4, which is equal to 20. J's score is minus 12. So, marks obtained for incorrect answer is minus 12 minus 20 is equal to minus 32. So, marks given for 1 incorrect answer is minus 2. Therefore, number of incorrect answers are minus 32 divided by minus 2 is equal to 16. So, the incorrect answers for the question is 16 incorrect answer. For Radhika, it's 10. Okay, so we'll go to the next example 3. So, example 3 is a shopkeeper earns a profit of rupees 1 by selling 1 pen and incurs a loss of 40 paise per pencil while selling pencils of her old stock. First question, in a particular month she incurs a loss of rupees 5. In this period she sold 45 pens. How many pencils did she sell in this period? Second question, in the next month she earns neither profit nor loss. If she sold 70 pens, how many pencils did she sell? So we'll see the solution for the first question. Okay, so profit earned by selling 1 pen is equal to rupees 1. Profit earned by selling 45 pen is 45 rupees, which we denote by plus rupees 45. Total loss given is rupees 5, which we denoted by minus 5 rupees. Profit earned plus loss incurred equals to total loss. Therefore, loss incurred equals to total loss minus profit earned, which is equal to rupees minus 5 minus 45. Rupees minus 5 minus 45 equals to rupees minus 50, which is equal to minus 5000 paise. Loss incurred by selling 1 pencil equals to 40 paise, which we write as minus 40 paise. So, number of pencils sold equals to minus 5000 divided by minus 40, which is equal to 125. So, we'll see the next question, this second question's solution. In the next month, there is neither profit nor loss. So, profit earned plus loss incurred equal to 0. Therefore, profit earned equals to minus loss incurred. Now, profit earned by selling 70 pen is rupees 70. Hence, loss incurred by selling pencil equals to rupees 70, which we indicate by 70 or minus 7000 paise. Total number of pencils sold equals to minus 7000 divided by minus 40, which is equal to 175 pencils. Following this, we have the exercise 1.3 here. They have also given what we have studied in the lesson, and they have given it very shortly. If you want, you can just revise it in your book. So it will be easy for you to understand every concept. Only 8 points. I think it's in the back also. Wait, we'll check. No, this is the only page, so you can read it easily and grasp every point so that it will be easy for your exam revision or self-work. If you like this video, like, comment, share. Please do subscribe and click the bell button so the video I post will reach you through notifications. Thank you.